Hello, this is our presentation on WPA2 Cracking, presented by me, Chris Lattman, and Daniel Chiba. So the software that we use to perform this cracking is the AirCrack suite. AirCrack refers to both the package of Wi-Fi sniffing tools outlined in this slide, as well as the particular program, AirCrack NG, that cracks a password from a captured handshake. AirMon, which is part of AirCrack, is used to set a Wi-Fi device into monitor mode, which is required to stage this attack. AirOdump is used to capture handshakes from the access point, and AirReplay is used to send deauthentication packets, forcing a client to disconnect from the access point, which results in EAPOL frames being exchanged. More on that later. AirCrack essentially performs a dictionary attack on an access point, meaning it only tests potential passwords from a provided list. The benefit of this attack is that the brute forcing of these passwords is done locally on the attacker's computer, which means that the access point has no idea that potentially hundreds of thousands of passwords are being tested against it. However, this attack does require at least one client to be connected to the access point. Otherwise, this attack will not work, and that is due to the deauthentication part. Wi-Fi essentially uses a four-way handshake outlined in this picture from IEEE. The access point and the client exchange information, the access point being the authenticator and the client being the supplicant in this image. And in particular, they share nonces and message integrity codes, or MICs, which are more or less message authentication codes used to verify the integrity of the data being shared between the two parties. Here's an image of the four-way handshake. This picture shows the various nonces and MICs shared between the client, which is the supplicant, and the access point, which is the authenticator. You can also see some keys generated by each party. These keys are relevant to attacking WPA2. The first relevant key is the pre-shared key. It is simply the Wi-Fi password to the access point. The pre-shared key is used to generate the pairwise master key, which in turn is used to generate the pairwise transient key. This process is described shortly. The key confirmation key, which is part of the pairwise transient key, is used to generate a message integrity code, which AirCrack uses to validate its guess on Wi-Fi password. The Extended Authentication Protocol over LAN, or EAPOL, defines a standard for Wi-Fi negotiation. Here is the frame of this protocol. Two of the relevant parts to attacking WPA are highlighted in red. The key nonce, which is either generated by the client or the access point, and the MIC, which again serves as a message authentication code for integrity verification purposes. Here's what an EAPOL frame looks like in practice. In Wireshark, we see the WPA key nonce highlighted and other relevant fields are shown as well. In the second, third, and fourth EAPOL frames, a MIC is included since the pairwise transient key has been generated. So to generate a pairwise master key, the router uses a PBKDF2 algorithm iterated over 4,096 times. The pre-shared key serves as the password to this algorithm, and the SSID name of the access point serves as the salt. The pairwise master key is technically the first 32 bytes of this function's output. To generate the pairwise transient key, a PRF or pseudo-random function is used. As you can see in the second picture, it internally concatenates HMAC SHA-1 repeatedly over a defined number of bits. The key confirmation key used in WPA2 is the first 16 bytes of the pairwise transition key. The message integrity code is generated by using the key confirmation key as input to a little-known algorithm called Michael, which is essentially a message authentication code. Here's an example of the MIC in an EAPOL frame, highlighted. And here we demonstrate an attack using this suite.